exponential equations. Okay, so an exponential equation is exactly what it sounds like. Like you are going to have a base with an unknown exponent, and then you'll have a base with another exponent, and we're going to have to figure out the missing piece of the exponent. Okay, and up until now, you guys have never really solved for missing exponents. So I'm going to teach you how we do that. If you look at these steps are actually really helpful. It says step number 1, you want to rewrite both sides of the equation with the same base. So if you guys look at this example, these already have the same base. When they already have the same base, it is extremely easy to solve, because if the bases are the same, doesn't that mean their exponents would have to be equal? They might look different right now, but we could set our exponents equal to each other and solve for y. But if the bases are different, we're going to have to figure out how to change one of the bases to match the other one. Okay, so once we do that, we forget about the base, we just set exponents equal to each other, and then we solve for this one says solve for x, but it's whatever the letter is, whatever the variable is. Okay, so down here at the bottom, we're going to start with some easy ones. Okay, we're going to start with the ones where the bases are already the same. Okay, so take a look at example number 1. Do they have the same base? Okay, so make sure you guys are watching. If the base is 5 and this base is 5, then in order for these two to equal each other, their exponents must be equal. So you don't have to use the 5s anymore. We're going to kind of just ignore the 5s, and we're just going to set this exponent equal to this exponent. So if we do that, look what happens. Is that even an equation that I have to solve? No, this is just the answer. Now that's way too easy. I'm never going to give you that kind of problem on a test because too simple. If we move to this one, which was the example at the top, do they have the same base? Okay, so again, as long as their bases are the same, all you have to do is write this equals this. So you set their two exponents equal. So I would write 5 plus y equals 3. Now this one we have to solve, right? It's just a one-step equation though, so how do I solve it? Yeah, your answer was right. I just wanted to say what the step was. Okay, so we subtracted 5 from both sides. We got an answer of y equals -2. Now the last one, are the bases the same? Okay, so let's set this exponent equal to this exponent. So we would take 1x minus 5 equals 3x plus 13. Now this is still just like a multi-step equation that has variables on both sides, which you guys have been doing since pre-algebra days. What would you guys do first? And it doesn't have to be my way. Just tell me what you would do. Okay, so Caden, I know why he's doing that. He's subtracting x to keep the x term positive, right? I'm assuming. So I always like to take the one that's on the right and move it left, but in all honesty, it really doesn't matter. So I'm just going to do it his way just to keep that x term positive. But again, if you had moved your x the other way, you'd still end up getting the right answer. 3x minus 1x is a positive 2x, and then you just bring down that 13, the plus 13. Now, since Caden moved the variable to the right, and mine is normally on the left, typically I move my constant to the right, but here it would not make sense to move the -5. So what am I going to move? We're going to move the 13 by doing subtraction. Yeah, so that would be -18 equals 2x, and then we're just going to finish with our division step. There you go. Now again, the final that you guys are taking this term, this is the first time I'm going to use this final. It's a new final. I printed it out, but I haven't even really taken that much time to go through it piece by piece. However, I can almost guarantee that if there's an exponential equation on your final, it is not going to be one of these. Because like I mentioned before, these are easy because the bases are already the same. When we test you, we're going to want to do it, make sure that you guys understand how to change one of the bases or both of the bases to make them match. Okay, so when you guys turn the page, now we're going to start working on some of these exponential equations where the bases are not the same. This is where your calculator is going to become your best friend. Okay? Now, when I look at this, I see that this side has a base of 6, and this side has a base that is 1296. It would not make sense for me to try to change this 6 to a 1296 to some power. 1296 is already bigger, right? So it wouldn't make sense. This one seems like, okay, I wonder if I could change 1296 to be 6 to some power. Because if I can, then that would make the most sense, because then this one's already a base of 6, and then that one will have a base of 6. So there's no easy way to do it other than guess and check. Now, you guys are all smart enough. You know that 6 to the first would be 6, and 6 squared is 36, right? So I would just expect you to pick up your calculator, and I know you already know the answer, at least I think you do, but type in 6, hit the caret button, and then try 3. Okay, just hit the up arrow, change that 3 to a 4. Okay, so I'm going to tell you right now, your exponents are never going to be that large, because if you think about what an exponent is, it's that base multiplied by itself over and over again, so your numbers get really big really fast. So there's no reason to type in a 1 or a 2 into your calculator, because those are ones you usually know off the top of your head. I would always start with 3. So like I tried 6 to the third, it was only 216, but as soon as I changed it to 6 to the fourth in the calculator, it gave me 1296. So we have just found what we're going to rewrite this side as. So you want to leave the left side alone, just bring that down, and on the right side, instead of writing 1296, we're replacing it with 6 to the fourth. Now, doesn't that look like a problem that was on the front? Bases are the same, so now what do I do? Yeah, we just drop the base, right? We're going to set this exponent equal to this exponent. So we're going to write 3x plus 1 equals 4. As soon as those bases match, you no longer need the base. Okay, so then how would I solve this? Yep, we subtract 1. 4 minus 1 is 3. And then we're going to divide by 3. So we get an answer of x equals 1. So in a situation like this one, when the number over here is just a whole number with no exponent, typically you're going to just always try to change it to whatever, you're going to always try to change it to this base to some exponent. Okay? Are we good? Now, when you look at the bottom slide, there is a rule in Algebra 1 that you would have learned, maybe even pre-algebra. It kind of just depends on when you went through the curriculum. But any base raised to, does anybody remember what power it is where you'll always get an answer of 1? No, because if you raise something to the first, it's just that number. So think of the number right before 1. So any base that is raised to the 0 power always equals 1. Okay? Now that's going to help you because if the right side of the original equation, or I mean it could be the left side, whatever side the 1 is on, couldn't I technically change this to any number to the 0 power? I could change this to 15 to the 0. But that wouldn't make sense if this one's already a 6. If I can change it to any base I want as long as my exponent's 0, then it would just make sense to change this to 6 to the 0 power. Now if this number over here, if this base had been a 10, I would have made this one 10 to the 0. Okay, so if you guys ever see a 1, you are always going to change it to this base raised to the 0 power. Okay? And again, that I used to teach exponent rules, I feel like in Algebra 1B, then it got moved into 1A, and then now I think it's even in pre-algebra. And I know I went through my pre-algebra students and we talked about 0 power. So you guys have heard that before. You just may not remember it. Okay, so now that they both have a base of 6, we drop the base and we just set our exponents equal. So I'd have 3x plus 1 equals 0. And it's just 2 steps. We're going to subtract and divide. And yes, it is completely acceptable to end up with decimals or fractions. It is fine. So I would subtract 1 and get -1. Then I would divide by 3. And you guys know me well enough by now. This is a fraction that does not reduce. So of course I just left my answer as -1/3. I mean, why bother typing it in if it's already in lowest terms? Now if you did type it in, you can write it as -0.3 repeating. And that's fine. The only time I don't really like you guys to write decimals, I don't mind it if it's a repeater, and I don't mind it if it actually comes to an end. But if it is some crazy decimal on your calculator that all the digits are different, there's no pattern, leave it as a fraction, okay? You guys okay with that one? Okay. That's what I said. It was going to be pretty quick. All right. When you guys turn the page, there is another rule in algebra, pre-algebra, whatever, about exponents that makes you flip a fraction or flip a number upside down. Okay? When we have a 0, it just gives us an answer of 1. When we have positive exponents, we were never having to like flip it upside down. Do you guys remember what kind of exponent makes you flip it? A negative. Good? Okay. So, the minute I see this fraction over here, I immediately started thinking, okay, wait, that's just the number 625 flipped, right? If you had 625 as a whole number, it would be 625 over 1. So all they've done is the reciprocal. They flipped it upside down. Well, in math, if you have negative exponents, you actually flip your number. That's all a negative exponent means. People used to think that if they had a negative exponent, their answer was going to be a negative answer. And I'm like, no, that negative literally just means reciprocal. So if I were to write 3 to the negative second, this is what it means. the reciprocal of 3 squared. Well, what's 3 squared? 9. And then how would I flip a 9? Yeah, that's all it is. So it doesn't mean that your answer is going to be negative. It just means, hey, don't forget to flip it. Okay? So, if this has a base of 5, let's see what exponent would give us 625. So again, you guys know 5 to the first is 5. 5 squared is 25. So you already know those two. So start with 5 to the third. See what you get. Okay, 125 is still too small, so then try 5 to the fourth. Okay, so if 5 to the positive fourth is 625, then 5 to the negative fourth is 1 over 625. So we are going to leave the left side as is, but the right side is now 5 to the negative fourth power. Okay, so now since the bases match, we're going to ignore the base. And we're just going to set this exponent equal to this exponent. So I'd have 4 minus 1x equals negative 4. That will end up being a two-step equation because we will have to move the constant and then we will have to do division. If this had been a positive 1x, would I have to divide by positive 1? No. But since it's negative 1, I will have to do the division step. We're going to start off by subtracting that 4. Yep, so you end up with negative 1x equals negative 8. And again, like I said, if this were positive 1, you'd be done. But because it's negative 1, we need to do division, and that turns our negative 8 into positive 8. Yep. Yes. Yeah, so just give me a second and I'll let you see, okay? Okay, so when you guys, is that enough room right there? Caleb? Is that enough? Okay. When you guys take a look at this one down here at the bottom, the one on the left, I see that this one has a base of 2 and this one has a base of 4. Obviously, they don't match each other, but I think what confuses people is they're like, well, there's already an exponent on each one, and all the previous problems, there were no exponents, right? We had to find the exponent. So what we're going to have to do is sometimes we have to change one base to match the other, even if it already has an exponent. And sometimes you have to change both bases. Sometimes you have to change one to match the other, or sometimes you have to change both. So I would never rewrite the number 2 as 4 to some power, because 4 to the first is already too big. Is there a way, so Caden, is there a way to turn this 4 into a base of 2? Not 2 to the 1, 2 to the second. Okay, so now listen. Here's the most important part. If this 4 is the same as 2 squared, what happens to the exponent that was already there? So it doesn't disappear. I'm going to keep it, and where is it going to go? It's going to go right next to this 2. So since it's an expression, I should probably put it in parentheses. When you said it was going to double, you're right, because I will have to distribute that. but I just wanted to make sure, like, this is how we write it. So you change the 4 to 2 squared, we bring down the existing exponent and just attach it to the new exponent. Now, nothing has to happen over here on the left side because it already had a base of 2. So, listen, can you guys look up here? If this were a 6 and this were a 36, it would make sense to change the 36 to 6 squared. Most of the time, it's going to be numbers that, like, you recognize, okay? Now that the bases are the same, let's set this exponent equal to this one. So I would have 1x plus 3 equals, now look, you guys can just bring this down or you can distribute. I'm going to go ahead and distribute it. I'm going to do 2 times x, which is 2x, and then 2 times negative 2, which is negative 4. And then it's just a matter of moving x's around and moving constants around. So I'm going to do, remember earlier, we ended up moving the variable to the right, even though that's not typically what I do. I'm going to do that again just to keep my x positive. But you guys don't have to do it that way. You know, I don't normally do it that way. I figure a lot of you do just to keep things positive. So I subtracted the 1x, brought down the 3, equals, and then this became 1x minus 4. And then we have to move the minus 4. So I'm going to add 4 to get 7. And because it says 7 equals 1x, do we have to divide by 1? If you guys divide 7 by 1, isn't it still 7? Yeah. So getting an answer of 1x equals something, you're done. Now, if that's going to bother you, I mean, obviously, yes, you can do this just to have it be the letter x, but it does not change anything. And then for the last one. Okay, listen, this one's the smaller one. So what we've been doing is trying to change the bigger one to match this one, right? Okay, well, 25 to the first is 25. 25 squared is 625. So I can't turn this one into 25 to any power. So if I can't change this one only, that means I have to change them both. But you guys, when you see the number 25, what number comes to mind? Don't you immediately think of 5? Because I think, okay, well, 25 is 5 squared. What about 125? It's 5 to what power? You guys already typed it in earlier. It was 5 to the third, wasn't it? So we can rewrite both sides with a base of 5. They both had exponents to begin with, and now they have a new exponent, so you will have to bring the x minus 1 down and attach it to the 2 on the left side, and you will have to bring the 4x down and attach it to the 3 on the right side. So this is a case of, okay, I have to change both of my bases. But if you guys had seen, like on one side, if you had seen a 49, and then the other one, you had seen some much bigger number. What number comes to mind when you see 49? 7 squared, right? So a lot of times, it'll be pretty obvious to you what number to change it to. It's going to be one that you recognize, hopefully. Like if you see 16, I think 4, because it's 4 squared. All right, now our bases match, so we're going to take this exponent and set it equal to this exponent. Won't we have to distribute over here? And that would become 2x minus 2. Now on the right side, it's just 3 times 4x, which is what? 12x? Yep. Now this is a case where you guys know I usually take this variable and move it to the left. Well, I can't do that, because if I bring this way, I have nothing on the right side, and we don't want that. So this one you actually do have to subtract the 2x, no matter what. So negative 2 equals 10x. And then we are going to divide by the 10. Now look please. This is clearly a fraction because the top is smaller. Those numbers are easy for you guys to reduce. So if you chose to leave it as a fraction like I usually do, wouldn't we just divide them both by 2? I mean, you guys can even type that into the calculator. You can type it in as 2ABC10, and it'll reduce it for you. Yeah, now if you typed it into a calculator, if you took negative 2 and divided by 10, is it a decimal that comes to an end? Well, type it in and tell me. Negative 2 divided by 10. So since this fraction can turn into a decimal that stops, I am 100% okay with you writing it as a decimal. I prefer the fractions, but some people don't want to have to bother reducing fractions, so they'd rather just go ahead and turn it into a decimal. So I get that, but either one is acceptable on that one. Now I want you to do me a favor. Before I stop recording and before I give you the practice page, I want you to write these problem numbers down, okay? This one that we just did right here, this is going to help you with number 7 on your practice page. Number 7 on your practice page, you will have to change both bases, okay? Everybody have that written down, the 7? Okay, then, are you done? Okay, this one up here, the negative exponents, you only have 2 of those, I think, yeah. So it's number 5 and number 10. So when you guys get to number 5 or number 10 on your practice page, if you're struggling, refer back to this one. Okay, and then go back a page. I'm going to tell you which ones you'll use the 0 on. That is just number 3. So number 3, you should rewrite one side with an exponent of 0. Now all the other problems, with the exception of maybe 1 or 2 of them, you will just have to change one side to match the other side, okay? So these are going to be number 1, 2, 4, 6, that's it. 1, 2, 4, and 6. And then they were really nice to you, and problem number 8 is one that already has matching bases. Now I never mentioned number 9, and we're going to do number 9 together. Okay? So when I give you your paper, don't start on it. Let's just get number 9 over and done with, and then you guys can work on the others on your own.